Series and parallel circuits, Kirchhoff's current law. The first principle to understand about parallel circuits is that the voltage is equal across all components in the circuit. This is because there are only two sets of electrically common points in a parallel circuit, and the voltage measured between sets of common points must always be the same at any given time. Therefore, in this circuit, the voltage across R1 is equal to the voltage across R2, which is equal to the voltage across R3, and in this case, equal to the supply voltage or the battery. We can immediately apply Ohm's law to each resistor to find the current because we know the voltage across each resistor, 9 volts, and the resistance of each resistor. Therefore, in this circuit, the current in R1 is equal to 0.9 milliamps, the current in R2 is equal to 4.5 milliamps, and the current in R3 is equal to 9 milliamps. At this point, we still don't know what the total current or total resistance for the parallel circuit is, so we can't simply apply Ohm's law to the total resistance. However, if we think carefully about what is happening, it should be apparent that the total current must equal the sum of all the individual currents in the resistors or in each branch. We know from Ohm's law that the total voltage across all the resistors is equal, so that the voltage or the total voltage is equal to I1 times R1 is equal to I2 times R2 is equal to I3 times R3. But the total voltage is also equal to the total current times the total resistance of the circuit. Or, rearranging the terms, that the total current is given by the total voltage all over the total parallel resistance, or RT. We know that the total current is going to be equal to the sum of all three currents, that is I1 plus I2 plus I3. And we also know that VT divided by RT, or the total voltage divided by the total resistance, is equal to the VT all over R1 plus VT all over R2 plus VT all over R3. Or, dividing both sides of the equation by VT, we get 1 over the total resistance, or RT, is equal to 1 over R1 plus 1 over R2 plus 1 over R3. This gives us the rule for calculating equivalent resistors, at least in 3 parallel resistors, as in this case. The total resistance, or 1 over RT, is equal to 1 over R1 plus 1 over R2 plus 1 over R3. This also leads us to Kirchhoff's current law, which states, the current entering any junction or node is equal to the current leaving that junction. A node being defined as electrically connected point in a circuit. Another way of stating Kirchhoff's current law is all currents entering the node sum to 0, where the currents entering are positive and the currents leaving are negative. Here is another way of looking at the same circuit. Stay tuned to this site as I'll be diving into more information from my electrical courses. In the meantime, take advantage of the availability of my 50-page electrical power crib sheets if you haven't already downloaded them. Simply fill out the information request when you go to this website. You can also directly access my StanStore courses at this website.